So here's my attempt to help you get ready for your quiz tomorrow, even though I can't be there with you to help you get ready. I'm going to walk through each of the examples on the review with the answer key and explain where everything came from so that hopefully if you get stuck, this will help you figure out how to do it on your own for tomorrow. So our first example is given a verbal transformation, we need to write the equation. So what I did was I looked at the information we were given. We know that it is a horizontal stretch by 4. Now anything that's horizontal gets grouped with the x, and it doesn't look like what we think. So it looks like it's a compression when it's in the equation because we have to take the reciprocal of that 4 when we put it in the equation with the x. And then we have a vertical shift down. Anything that's vertical is outside of the asylum, and it is normal. So we have this -3 on the end, which looks like it's going down 3. Our next example is an absolute value transformation. So the first thing that we want to do is identify the critical point. The only time that the critical point changes is if you have a shift. Because if you're multiplying or reflecting, remember the critical point for all of the parent functions is 0, 0. And when you multiply by 0, it stays 0. So when you're shifting, adding, or subtracting to the equation, that's when the critical point changes. So ours is still 0, 0 because we don't have any shifts. Looking at the verbal description of what's going on with this graph, we have times a negative on the outside of the equation, so that means that it's a vertical reflection because it's outside the asylum. Inside, grouped with the x, it looks like a stretch of 3, which means it's actually a horizontal compression by 1/3. So the way that I set up my t-chart was the first 2 columns is for the parent function. The parent function is our absolute value, so that first x, y are for the parent function. And then anytime there's multiplication or reflections, I put those in another column. So our horizontal compression by 1/3 will multiply all of our x values by 1/3, so you can see that in this column. And then the vertical reflection multiplies all of our y values by a negative. So I plotted my critical point on the graph. My critical point was 0, 0. And then because we didn't have a shift, the second set of values in our table were ordered pairs to plot on the graph from the critical point. Domain for an absolute value function is all real numbers, and that doesn't change regardless of the transformation. And if we look at our graph, because of that vertical reflection, our y values are all less than or equal to 0. Next, we have a square root function. We have, again, inside the asylum grouped with the x, we've got 2 things going on. We've got multiplication by a negative, which is a reflection. Because it's inside grouped with the x, it will be a horizontal reflection. It looks like we have a compression of 1/2, but the reciprocal of that is 2, so we actually have a horizontal stretch of 2. And then outside the asylum, we have a -3, so it's going down 3. Because we have a shift that changes our critical point, our only shift is vertical, so our critical point is 0, -3. Again, in the t-chart, I start, the first 2 columns are my parent function. My parent function in this case is the square root, so I took the square root of those values. The only ones that I do in the next set of t-chart is any multiplication. I do the shift with the critical point, and I do any multiplication in the t-chart. So we had 2 multiplications in this case. We had the horizontal reflection, which is multiplying our x's by a negative, and we had a horizontal stretch of 2, so we're multiplying all of our x's by 2. So we can see that here I'm multiplying all of my x values by -2. After I have my new set of t-charts, I graph those as direction from my critical point. So for example, this one, from my critical point, I went left 2, up 1 to get the point on the graph right here. And I plotted the next one, and of course the last two wouldn't fit on the graph. For our domain, anything under a square root needs to be positive. So you can either look at the graph and see that we're graphing off to the left of the x value of 0, and notice how the domain value links to the x coordinate of the critical point. That will always happen. Same thing for the range value. Our range value starts at -3, which was the y value of our critical point. So that gives you a place to start from when you're looking for domain and range if it's not all real numbers. Another option with the square root is to set what's under the radical greater than or equal to 0. What you have to be careful of is when you multiply or divide by a negative, the inequality flips. So make sure that your domain and range match what's going on in your graph. We have less than or equal to 0 for our domain because of that horizontal reflection, and we have our range of y is greater than or equal to -3 because of that vertical shift down. Next is our step function, and I choose not to graph the step function with a t-chart because the t-chart ends up looking like a line, because you really need to graph some decimal values in order to see the steps. So what I do is I think about that first bar for the parent function, and I shift or stretch or compress or reflect that, and then I continue the pattern from there. So in this case, all we have is a shift. Inside our asylum, it looks like we're going to the right 2, but our critical point is -2, it's left, it's going opposite of what we think. Outside our asylum is down 5, so that is the y coordinate of our critical point because that's normal. So what I did was I took this yellow bar that I just graphed for you, that's the first bar for the step function for the parent, and I moved it left 2, down 5, so I actually started right here with my new graph, and then I continued the pattern from there. Because there's no stretching or compressing, each bar will be 1 unit long, and there will be a space of 1 unit vertically between the bars as they step up. Domain is all real numbers. Again, for the parent function, it's all real numbers, so no matter what transformation you do, it will still be all real numbers. And our range, because we didn't have any vertical changes, it's integers. All right, on to our parabola. So again, we've got a shift on this one. Inside the asylum, it looks like we're heading left 1, but it's really a shift of right 1 when you look at the critical point. Outside the asylum is a +6, so we're going up 6. The other thing we have is the negative outside the asylum, so that will be a vertical reflection or a reflection across the x-axis, depending on how you think about that. So in the t-chart, we've got our parent function in the first 2 columns. And then with the critical point, I take care of the translation. So the only thing that I put in my new t-chart is that vertical reflection. So all of my y values become opposite. So when I graphed, I started by plotting my critical point, and then I used those values in the t-chart as directions from my critical point. So from my critical point, I went left 2, down 4, and then I went left 1, down 1, and so on until I had my parabola. For the quadratic, the domain is all real numbers, so that does not change with any transformation. And again, looking at the range, y is less than or equal to 6, and our critical point had a y value of 6. So those will match up, so you can check yourself as you're working through your domain and range. Because of that vertical reflection, our parabola is opening down, so our range is less than or equal to 6.